This is 6.4, day 2. We are practicing more factoring and some application problems in this lesson. All right, here's the first example. We're just going to continue making sure we understand how to do sum and difference of cubes. There will be some other factoring methods that you did learn yesterday and in chapter 5 that will focus on factoring too. So we have 27x cubed minus 8. So this is a difference of cubes. So we want to rewrite it so that it is a perfect cubed minus a perfect cube. So I can rewrite 27 as 3 times 3 times 3. So that's 3x raised to the third. And then minus 8 can be rewritten as 2 times 2 times 2, or 2 cubed. And then we go ahead and put this a and this b into the rule. So we say 3x minus 2, that's your a minus your b, and then parentheses 3x squared plus 3x times 2, and then plus 2 squared. And now we just need to clean up that second parentheses. So 3x minus 2, and then 3x times 3x is 9x squared. 3x times 2 is 6x, and then 2 times 2 is 4. Now we have it in factored form. Let's just do one more of these. This is now a sum of cubes where we start off with x to the 6 plus 64. I've done the first step where we want to rewrite x to the 6th as a perfect cube. So x squared times x squared times x squared is x to the 6th. And then 64 can be rewritten as 4 times 4 times 4, which is 4 cubed. So we are going to identify the a and the b again. This is my a value, and this is my b value that I'm going to substitute into my rule. So my a value is x squared. My b value is 4. So the first parenthesis is going to be x squared plus 4. And then the second parenthesis is going to be a squared, or x squared squared minus x squared times 4, a times b, and then plus b squared. Now we got to clean up that second parenthesis. So x squared plus 4 stays as it is, and then x squared squared is a power to a power rule. So x squared squared is x squared times x squared, or x to the 4th. We multiply those powers. And then negative x squared times 4 is negative 4x squared. And then 4 times 4 is 16. All right, let's go on to our application problem. This will finish our lesson for today. The question is, the volume of a rectangular prism is modeled by this function. What I do want you to write down is just go ahead and write this function down. The volume of x equals x cubed minus 8x squared plus 19x minus 12, which is the graph below. It says identify the x values for which the volume would equal 0, and use this graph to factor it. So go ahead and draw this graph also. We'll give you some time to do that. And then I highlighted 3 important pieces. The x-intercepts. The x-intercepts are 1, 3, and 4. The x-axis represents the height of the box. The y-axis represents the volume of the rectangular prism. So if I go down here and just remind you what a rectangular prism looks like from geometry, a rectangular prism is a 3-dimensional shape that looks like this. It has a length, a width, and a height. This is our height, is what we're focusing on. And there's 3 different heights that they're giving us in this equation. And they say, when would the height, the volume be 0? So if I look at this graph now again, the graph is showing 3 x-intercepts. One x-intercept at 1, another x-intercept at 3, and the last intercept at 4. That's when the volume would equal 0. So when does the volume equal 0, the box would be flattened out, is when x equals 1, when x equals 3, and when x equals 4. Those are your 3 x-intercepts. This is a cubic function, so you can have up to 3 x-intercepts. They are also called the zeros of the function. The last thing it says is then use the graph to factor the volume of x. So we want to write it in factored form. So what we do is have to think opposite here. The volume of x equals, and I have 3 parentheses there. In factored form, it would be x minus 1, x minus 3, and x minus 4. The reason why that is, if I think about that in factored form, and I set this equal to 0, and I solve it for x using the zero product property from earlier in chapter 5, the zero product property says is I would set each of those factors equal to 0 and solve for x, which would then be my x-intercepts, or my zeros. So if I look at this, I would add 1, I would add 3, and then I would add 4. Look at those are my x-intercepts. They are when the value of the volume would equal 0. So 2 parts to that. Identify the values for which the volume would equal 0, so those are your x-intercepts, 1, 3, and 4. And then use the graph to factor the volume. So now it is in factored form. Remember, that was an original cubic function. So you'll see some problems similar to that in your homework in the application. This will be the assignment that you'll do in class. 6.4 day 2 on page 443. Just continuing with some more factoring problems and then a few application problems. We'll have that one due at the end of the hour. There won't be a video that night. Instead, there'll be a review assignment instead for your out-of-class work to help you prepare for your next quiz. Because we'll have a quiz covering 6.1 to 6.4.